Okay. So presently, the industry, as far as consider our India, the Indian countries, presently some companies are using the wired networks. Some companies are all implementing the WSN, and some also are going for the IoTs. So I will discuss here what are the wired networks options, the WSN options, and IoT. So WSN means wireless sensor network. So in front of you, there are some wireless nodes are there, and these nodes can be turned into the IoT devices. Okay, so these are the, you can say this IoT sensor node 1, node 2, etc. Actually, these are the WSNs, that is wireless sensor nodes. Okay, sensor node, and it can be implemented in wireless sensor networks. You can design it, but what I'm showing here is these sensor nodes. Actually, these are the sensor nodes can be turned into your IoT device. Just give the capability as an internet. Okay, just give the capability of an internet, and they will become your IoT sensors. So here you can see that one ARM processor is here, one small ARM board is there. I have used it. It is a 32-bit ARM processor, and along with that, some flash programming is programmer is there on the in this board, and some header pins. Only the basic model is there. I have used it, and it is available in the cost of an $5. Okay, so just purchased it, you can get the 32-bit processor. And all these another PCB is designed for the sensor interfacings. So for 5 to 6 sensors, signal conditioning circuits are designed on this board along with the communication, that is Zigbee, and this is the battery. And all these sensors are interfaced through this R board. The data is processed and sent that through Zigbee to the base stations. Okay. So here, if you design this IoT device, just give the capability Wi-Fi or Bluetooth or anything, or you can use a Zigbee also. Second option, that is Zigbee also. And all these nodes interface to the processor, collect the data, and send it towards the base station. So this is the base station. So here, instead of a base station, you can design here your IoT gateway. This is your IoT gateway. So instead of this base station, you can connect here IoT gateway. So which this the job of the IoT already IoT gateway is already explained. They receives the heterogeneous data from the IoT sensor nodes and make it in standard format and transfer towards the IoT cloud, put onto the cloud. So we have visited the different companies and industries, and on extensive survey, it is found that some industries are using the wired network. So here, this is the textile industry. We have focused on to the textile industry, and we have visited the Fabtech project engineers textile division in Ikatpur, Sangola, wherein they are manufacturing the cotton yarns. They are manufacturing the cotton yarns, and to maintain the quality of that cotton yarn, they have maintaining that internal temperature, that is 32 degrees Celsius, and relative humidity is 55% RH. So temperature they are meant 32 degrees Celsius, and RH, that is relative humidity, is about 55% RH. So there are four sections in this industry, that is textile industry. That is preparatory section, blower section, spinning section, and ring corner section. So we have implemented our WSN, and instead of an WSN, you can design your IoT system, and you can implement here in these industries. And there is a requirement. Okay, huge requirement is there. So this is the internal arrangement. Here we have placed these sensor nodes in preparatory, in blower sections, which continuously these all these nodes continuously monitor the temperature and relative humidity around surrounding, and after manipulation onto the ARM processor, they send through that data through Zigbee to the base station. So here, instead of a base station, you can, if you want to implement the IoT system, so these IoT sensor nodes will take the data and will send that data through the Wi-Fi or Zigbee to the gateway. Okay. Now, as far as consider the site-specific variability, this is the humidity graph. See, the humidity is varying from 50% relative humidity, 60% relative humidity. Okay, this is the site specific variability is there, and As far as consider the temperature, we observe that the temperature is varying in the area, that is 29 degrees Celsius to 34 degrees Celsius. Okay, so 34 days. So this is the range, but this is the actual reality. But if you observe their meter, so they have installed, I'm just highlighting. If you observe their meter, the one meter, wired meter is present at currently in the textile industry. That device continuously showing 32 degrees Celsius and 55% RH. From we just visited at least 8 to 10 times in that industry. So it means that we have implemented our system 8 to 10 hours in that industry. Still their unit is continuously displaying 32 degrees Celsius and 55% RH. So this much scenario is there in presently in industry. So there is a requirement is there, advanced systems are required to measure the site specific variability, and you can design your IoT systems and you can implement here in the textile division. So we have implemented these wireless sensor nodes in different sections, and instead of this WSN, you can implement your IoT. Now here while implementing, we have used the different kinds of topology. So here this is the these are the sensor nodes basically, which collects the data transferred to the routers. These are the routers, and again this is one router, and is sent to the base station. So you can here use your IoT sensor. Okay, then this IoT sensor will transfer the data to the another gateway, IoT gateway, and from that gateway it transferred onto the another gateway and to the cloud, and finally data put onto the cloud server. Okay, so this is the way you can implement the IoT system. So why these two gateways are used? Because the distance, causes of the distance. So this is the huge area is there. The ring corner section is too long, and from that ring corner section to the base station, the distance is too far, and causes of the noise, the machines are generating the noise, and causes of the noise, the data is lost. The packets are lost while transmitting through the wireless. If the wireless transmission is there, then data gets lost. So we have to use the routers. Okay. So instead of using the routers, you can use the different gateways, IoT gateway. So another, we have also implemented this system in food processing industries. As far as the food processing, we have focused on to the milk dairy. So wireless sensor network is also implemented in milk dairy. So this is the internal view of the milk dairy, and you can observe that there is a requirement here. So the 5 tanks are there wherein the milk is stored, and the requirement is 8 degrees Celsius to 10 degrees Celsius. The temperature of that milk tank is maintained about 8 to 10 degrees Celsius. And they have again wired displays there. They continuously showing the 5 tanks temperature, and it varies from 8 degrees Celsius to 10 degrees Celsius. So we have implemented our WSN, that is wireless sensor network. Sensor nodes are placed. You can see here. I'm just explaining this one. So you can put your sensor to this tipping point. The tipping point is provided, and in that we have placed our temperature sensor, and we just measure the temperature of that silo tank. The name is given, that is silo. You can observe silo tanks are given, names are given. So these sensor nodes measure the data and transfer towards the base station. Like that, you can implement here your IoT sensor, okay, which measures the temperature, and through the wireless or Wi-Fi or Zigbee, they can transfer the data towards the IoT gateway. So here the gateway is placed. I am not shown here gateway. The base station is not there. So the data is, if you send the data to the gateway, from that gateway you can put that data onto the cloud. You can put that data onto the cloud. So in as far as concerned the food industry also, there are different parameters are there. You can observe to these advanced systems like WSN or IoT. But presently they are using the wired network. Presently they are using the wired network. Again, we have implemented the system in refrigerator sections of the milk dairy, wherein the ammonia gas is used. Okay, so ammonia gas is used for refrigeration to cool the systems or to provide the chilling temperature, they have used ammonia gas. But the ammonia gas is transported from one place to another place. Ammonia gas is transported from one place to another place. So they have placed the different wired sensors. Their sensor continuously monitors the concentration of the ammonia gas in the air. And if the concentration is more, they alarm the system. So we have implemented the WSN there, and the sensors are present on these nodes. They, yeah, I am not here explaining all the calculation, how the concentration is calculated. So all these node measures the concentration of the ammonia gas in the air, and the data is transferred towards the base station. Again, you can design your own system IoT sensor nodes. Okay, all these nodes can be turned into the IoT. I have already told you, just give the internet capability to them. They become say your IoT systems. So you can transfer all these IoT sensor the data to the IoT gateway, and from that gateway you can put that data onto the cloud. So again, we have implemented the system into the milk packetization sections, wherein the pressure sensor is used. Pressure sensor. Here another the requirement is that there is one supervisor is there in second diagram. In second figure, you can see that one supervisor is there, and the milk packets are coming here. And suppose this is the half liter milk packet is there, and they are continuously checking their weight of that milk packet. So the density of 1 liter is 1.026 kg, and for half liter is about 530 grams. So suppose half liter bag milk bag is there, then their supervisor continuously checking their weight 530 grams. Continuously at a regular interval they are checking, and if the weight is not correct, then just shut down this machine. They are shut down this machine. So we have designed one system. We designed the one pressure sensor. Using their pressure sensor, we designed one system wherein the milk packet is coming directly onto that board, and we are just measuring the weight of that milk bag, and it is about suppose 530 gram. It should be 530 gram, and that data is sent through this sensor node towards the base station. So here again you can implement your IoT sensor. You can measure the weight of that milk packet and directly send to the manager's cabin. So base station is placed into the manager's cabin, wherein the manager continuously watching onto their desktop. So huge requirement is there, and it is I would like to say that this milk industry has offered us project to design this system and design one professional system for them, and we did not accept it due to some reasons and due to causes of an cost. Their cost is very low. They are offering about 2 lakh rupees their project, but our calculation it's about 4 lakh. So it is too much differences there. So we didn't accept that, and so you can design. We have implemented WSN, but you can design your own IoT and you can implement in many industries. So I have explained here 2 industries. The third industry is here, that is sugar factories there, wherein the 99% alcohol is manufactured. Okay, and the concentration of alcohol gas in the air you can again monitor through these sensor nodes. So you can implement your IoT sensor nodes. Okay, so here sensor node is here, and you can measure the data. So you can design your own system, and but this advanced technology has some challenges: security challenges, privacy, some legal challenges are there, some bandwidth problems are there, and some customer expectation. The first one is the security. That is, security is not a new in the area of the information technology. So, but the user needs to trust that these IoT devices are secured from the malpractices, and its related data services are secure. And the experts are saying that if the poorly secured devices can affect the security, because all these sensor nodes have an capability to connect the internet. Okay, so internet means the cyber criminal can access your IoT device easily. Okay, and there are some examples are there. DAN attacks as is there in America, that is DAN DDoS attack is there. It means that the DAN is a company which is an internet service provider, and they have faced this IoT attack. There are millions of IoT devices which has the capability to connect the internet. They continuously access, and they send the request to their server, and their server becomes down. And and they reported after inquiry, they reported that millions of IoT devices access their server. Then another attack is that is casino attack is there, wherein all the casinos data is compromised by the cyber criminals, and they have captured their data. And then IoT BB monitors are present in they're using in the America, and they have reported, many parents have reported that these IoT baby monitors are accessed by the cyber criminals, and they are chatting, they are talking to they're speaking to their babies. So like that, there are various problems, security problems are there, and user has to take care of that securities. And the cyber criminals have different options. You can see here using this diagram, they can attack your IoT device, that is sensor node. They can enter through these wireless protocols. They can access your gateway, the ISP gateway, or in a cloud. So security issue is there. Then privacy issue is also there in IoT. The user need to respect their privacy. Okay, so it is big concern as far as privacy, because the user has the threat that surveillance and tracking. They feeling that somebody is keeping the surveillance and tracking them, and because all these IoT systems can be implemented through the smart home applications. So for smart home applications, IoT sensors are there, and all these IoT sensors are connected to the internet. But the cyber criminals can access these devices, and they can monitor your personal things. So privacy should be here. And recently, some experts are saying that if you ask any experts, and what is if you ask them what is the biggest headache of this 21st century, they will say you the IoT devices. If poorly IoT devices you use, then it will be big headache for you. There are some legal and regulatory issues are there, because till now the regulations are not clear, and that is why the cyber criminals are easily escaped. But there are some currently regulations like FTC is there, FFA, FDA, NSTS is there, EPA, NIST. All these are monitoring in the different sectors. Take an example like FAA monitor the driverless drones, then driverless cars. There are regulations are there, but still now the concrete regulations are not. That is why the companies are hesitate to implement the IoT systems in their industries. So third one is that is bandwidth. Sorry, fourth one is the bandwidth. So bandwidth problem is there, challenge is there, because suppose Cisco is saying 50 billion devices will connect to the internet. So all these require the bandwidth or space. So suppose all these devices connected simultaneously, so what will happen? The internet service provider will have big headache to provide all these devices a bandwidth. Okay, and if all these devices connected, then live streaming and live video will not be possible. Okay, so bandwidth issue is there. Then expectation, customer expectation. The customer have huge expectation as far as consider the IoTs, and that is why many IoT startups are failing. Many IoT startups are failing because of the customer expectation. Because suppose you handling with one customer and they have the different expectations, so these customers don't hesitate to go another vendor. So to retain the customer is very tedious task as far as consider the IoT. So these are some challenges also there. Advanced technology is there, but some challenges are also there. But we have to take care of all the challenges. We have to give the solutions to the user while designing the IoT system. So this is from my end, and informative to you. Over to you, sir.
Thank you, sir.
Thank you. Hello.
Thank you for your nice presentation on the Internet of Things. Of course, it is more useful to the specialization students who are taking electronics as their specialization. So I thank again Dr. Sachin Chavan for his very nice presentation. Over to Dr. Godke sir for the vote of thanks.
Thank you, Deshmukh sir. So, good afternoon to everyone. Respected resource person of today's guest lecture, Dr. Sachin Sawan sir. We have given nice lecture today. Respected principal of our college, Dr. P.R. Thorat sir. Respected Dr. Kothawade sir, Dr. Rahul Kulkarni sir, and Mr. Ashok Nalode sir, who joined our lecture. So, my colleague Dr. K.P. Deshmukh sir, Electronics Department Deputy Coordinator of this webinar, teachers, students who are attending this webinar. So it is really great that this webinar turned out to be very successful because totally near about 40 participants have attended this webinar. I am here to present the vote of thanks to the participants who made this event successful. First of all, I would like to thank to the speaker of today's webinar, Dr. Sachin Sawan, for giving valuable, informative, and good lecture on Internet of Things. He has explained all applications of Internet of Things and details about the Internet of Things. He is supporter for electronic subject. Also, he is supporter for science and technology because after future, we have a need of Internet of Things in industry, in world also. So we would like to thank to our principal, Dr. P.R. Thorat sir, for encouragement, support, and taking efforts to make this event successful. I would like to thank all participants, teachers, students who are attending this webinar. I also thankful to Dr. K.P. Deshmukh sir for nice introduction about this case lecture. I express my sincere gratitude to our science coordinator, Dr. T.N. Lokhande sir, DPT coordinator, Dr. Gurme sir, and I also lastly thank to our today's resource person, Dr. Sachin Sawan sir, for giving nice lecture on Internet of Things. Thank you all for making this event successful with your contribution. Thank you all.
Thank you, sir. Thank you.
Okay, thank you. Thank you, sir, for nice lecture given to us.
Thank you.
But today in our college, at the morning from 10 a.m., other
Okay.
guest lectures are also going on. That's
Alright.
why today, today participants are less because there are
Okay,
so
no
many
problem.
problems regarding their data, and lectures are also going on. So
Okay,
thank you, sir. Again, we arrange at morning
No
time
problem.
your lecture.
Okay.
Okay.
Okay. Thank you, sir.
Thank you, sir. Thank you.
Okay,
Nice
okay.
lecture given because today industry needs about the IoT. Thank you.
Okay. Thank you, sir.
Thank you, Dr. Godke sir, for the vote of thanks. Here we are at the end of our Zoom meeting. I shall take the permission of the head of the department and the principal that we will end the meeting here. I thank Dr. Sachin Sawan sir for his valuable presentation, which was useful for the electronic students. Thank you very much. I stop here. I end my meeting here. Thank you again.